Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and today is one of such events. If you want to find out more about the events we have, there is a link in the description. Click on that link and you'll see all the other events we have in our pipeline. Do not forget to subscribe to our YouTube channel. This way you'll stay up to date with all our future events and you'll get notifications when they start. And last but not least, do not forget to join our Slack community where you can hang out with other data enthusiasts. During today's interview, you can ask any question you want. There is a pinned link in the live chat. So click on that link, ask your questions, and we will be covering these questions during the interview. I also open this on my mobile phone, so I'm still sharing my screen, right? So then I see if something is in the live chat. But yeah, Adrian, if you're ready, we can start.
Definitely.
So this week we'll talk about trends in data engineering, and we have a special guest today, Adrian. Adrian is a returning guest. Now it's third time if we just count podcasts, but if we count other things like workshops, open source demos, and like I don't know what else, people probably know you already and have seen so many times. So Adrian is a co-founder of DLT Hub, and which is the company behind DLT. And this is one of the things we will talk about today too. But in general, we wanted to talk about trends in data engineering because this is when we launched our course recently, Data Engineering Zoom Camp. One of the questions there from the audience, from the participants, was how do you see data engineering evolving, and what are the trends in data engineering? And I realized that I don't know the answer to this question. I cannot really answer, and I thought who might have the answer. And then, of course, I thought about you, Adrian. So welcome to our event. Welcome to our podcast interview. It's a really great pleasure to have you again here.
Pleasure is mine to join. I don't have the answers either. I just have my view of what I can see, and I can speculate a little bit. I can talk about what I observed.
And this is what makes it interesting, right? I mean, everyone has opinions. And you're way closer to data engineering than I am. So we can talk about that. And as always, the questions for today's interview are prepared by Johanna Bayer. Thanks, Johanna, for your help. And before we go into talking about trends in data engineering, maybe, I know it's third time you will need to do this, but maybe you can give us, tell us about your background. Can you tell us about your career journey so far?
Sure. I was born in 1987. No, I'm joking. So basically, I started in data in 2012. I did 5 years of startups in Berlin. So building lots of data warehouses. Then I joined enterprise. I didn't enjoy working for an enterprise, so I became a freelancer for 5 years. And after 5 years, I wanted to do more than just being a freelancer. An agency wasn't it, since I don't enjoy managing agencies. So I decided to go for building DLT, which is the tool that I wish I had as a data engineer. Yeah, I guess this is the introduction.
Mhm. I like a tool I wish I had as a data engineer. Is it something you often use?
I use it all the time. So, when it comes to data engineering, you probably mostly do data ingestion as a data engineer. And there, the challenge is getting data from a weakly structured format like JSON from an API into a strongly structured format. So since DLT automates this process and much more, there's really no reason to do something else.
Mm-hmm. Do you remember last time we spoke? When was it on the podcast?
Just over a year ago, I think.
Over a year ago. So you already were at DLT and we were talking how, um, yeah, so I'm just looking it up quickly. The entrepreneurship journey from freelancing to starting a company. So DLT was already there and we were talking about your journey, like how exactly the switch from being a freelancer to being a founder, co-founder, how it happened. So I'm just looking. It's season 17, episode 1. So you can go to our podcast and check it out. So what changed since then? So it's been a year, and it's for me personally. Like before you answer this question, I really like coming to your office, and you always organize these nice events, meetups. And then I really liked coming to your old office. And for me, it was like, cool, you have such a cool office. And then more and more people were joining the DLT Hub. And then at some point, it was just the old office was just too small. And then you moved to another one, which is like even cooler. And it's always such a big pleasure for me to come to your office and like see like this vibrant company that you built. So it's amazing. But this is just an outsider view of somebody who just comes to your office maybe once in a couple of months. So can you tell us more what exactly has been happening since last time we
Yes.
spoke?
So, the office view is interesting because we started with squatting, like no joke. We were basically working from other people's offices. But what happened was, if you remember, I was talking about trying to create a standard in ingestion with DLT. And essentially, I think we succeeded with that. DLT has become an ingestion standard with Python. And I would say we managed to truly commoditize this market. So what do I mean by commoditization? Because to some people say it, but they don't really understand what it means. And let me spell it out. What are the implications? Well, commoditization in any market, when you do that, it means that you are turning, you're basically lowering the cost of production of something to become accessible for everyone. And basically, we've achieved to do this with DLT, not only on short tail, where vendors are already competing, so like on SQL databases, Salesforce, and the general connectors, but on long tail as well. So basically, people creating their own sources. And what this means fundamentally for the industry, it means that the value of what vendors offer currently these days is going down. So this is a challenge to the entire market to, let's say, get better at their offering and offer things that are not just here's a connector, which is kind of like low value, but actually a value proposition that is beyond just moving some SQL data.
Yeah. And so right now you are not like, can we say that you're actively working as a data engineer these days, or like what do you actually do at work?
To be honest, what I'm doing right now at work is I'm working on a DLT Plus and figuring out how we can make a meaningful product there. And what I mean, basically, we've been building DLT and we've been looking at what people build around DLT. And essentially, we are building the same thing that all these other smart people are doing, just in our version. And our version basically means the same thing that it means for DLT. So like best practices, um, high quality, and we try to go for innovation. So, just like DLT basically offers superior quality to almost, and I think to any integration that you can currently buy because of the schema evolution, alerting, metadata. DLT Plus aims to do the same. DLT Plus basically being the, let's say, data platform that you'd end up building with DLT.
But in terms of, so your actual work is figuring this out, like how exactly the DLD Plus will work.
Yes, as a
Uh,
founder, yes, as a founder, basically, it's all kinds of things from, let's say, deciding which risks you're going to take to explore different initiatives, right? Listening to people, testing things.
and
Right
as you
now,
listen,
sorry,
yeah,
and
sorry.
one of the things that I'm actually working on in preparation for our DLT Plus product is opening up a partnership network. So basically, just like I wanted to create a freelance agency, if you remember back when I was a freelancer, now I'm trying to create a partnership network where, let's say, everybody wins. So basically, that is aimed at maximizing value delivered to the customer, which will also be, let's say, the current consulting partners are basically people who are already deploying DLT and want to get more value out of it.
Mhm. And well, since you mentioned that this is not something we planned to talk about, but I'm I'm sure maybe there are some freelancers who are listening to our conversation right now. So if they want to reach out and learn more about like this partnership network, how should they find you? LinkedIn?
They can reach out on LinkedIn. They can find the partnership links on our website and apply. Essentially, this is mostly something for people who already use DLT. So if you already use DLT, just come forward.
And as you said, part of your job is listening to people, and I imagine it's also listening to their problems. And you've been in the industry, in the data engineering industry for 10 years or more, because you mentioned like working at startups for 5 years, then enterprise, and also 5 years of freelancing. And now you're running a company. So you've been in the industry for quite some time. And you probably remember like Hadoop times and I don't know. So what's happening in the industry right now? Like if you compare data engineering 5 years ago and data engineering now, um, how does it look like?
I
Like
would
what
say
are what things changed?
we have multiple fronts to discuss. So I would first start with the people, the data engineer. So I would say 5 years ago, there was a huge shortage of data engineers, and just about, let's say, anyone who could do, let's say, functioning integration could be called a data engineer back then. I would say this is slowly changing. So the field is transitioning from I can make something run to specialists. So what I mean here is I'm seeing more and more data engineers specialize into, let's say, data governance engineers or data quality engineers or streaming data engineers. And many of these skill sets actually have very little overlap outside of engineering. Um, Part of this is driven basically by requirements of the industry, like how you should deal with sensitive data or things like that. Or, for example, the energy changes in Europe, where now everyone and their grandma can have a solar panel on their house, and the system needs to understand what is the production, how can we bid for this, right? So it's completely different use cases.
And in terms of, well, since we have a course on data engineering, like in terms of, let's say, junior data engineering, like is a junior data engineer a thing these days, or
So I
like
would
you need to be an experienced software engineer now to enter the field?
So I would say yes, but it depends. You basically need to find a sweet spot of where you can help people. So specifically, I would say there is actually a huge opportunity now. Just like it used to be 7 years ago with data science, when people didn't know what data science was, and they just hire a data scientist, don't know what for, but just get them on board. Something similar is happening with AI, and I would say this is not happening yet in Europe. I'm seeing it happen in US and Asia. And basically, they have this idea that they will get huge ROI out of AI, and they're trying to figure out how to do that, how to go there, basically. Speaking of, this is another of those specialties. It's kind of like data engineers that build for AI.
Mm-hmm.
So I think this is an opportunity for some. Another opportunity could be just, there are still new startups being opened every day, and they need to build a modern data stack. This has become way easier now. You can literally, if you look, for example, in DLT's dependence on GitHub, you will find multiple free open source data platforms. So you can just drop in.
Mm-hmm.
Yeah, so the help here is basically being the person that can interface between technical and business. It will always.
Yeah. You mentioned one thing, this modern data stack. So how modern is it? It actually is. Because like I've heard this term some time ago, and I guess it was created like as kind of the opposite of like this slow Hadoop stuff. Perhaps, maybe correct me if I'm wrong, but like what it actually is and how modern is it?
Basically, modern data stack is pure marketing. It's not modern. It's just before modern data stack, there were people doing all kinds of things to build data warehouses. Vendors came and they created, let's say, packages of software between other vendors that you can put together to build a data platform. So for example, Fivetran with Snowflake and Looker, I don't know, just an example.
Mhm.
Um, and basically, vendors needed a way to communicate this and to be able to sell together. This is what the modern data stack is. I would say it was very effective as marketing because people identified and they talk about this concept. Now, is it modern? I would say it never was to
Mhm.
begin with. Now people are talking about postmodern data stacks. I would say a modern data stack is a data stack where you're not just like human middleware deploying some kind of vendor software, but rather something that is way more efficient than we were doing things 10 years ago. So this is actually something that we think we're working on. People call this, we don't call it anything. People call it the postmodern data stack, which is basically using open source technologies put together to achieve way better, higher quality, better efficiency, lower
Mhm.
cost than anything you can get from the vendor.
Because what you mentioned is Fivetran, Snowflake, what was it, Looker. None of
Yeah.
this is open source, right?
Yes, pretty much. I mean, not those actual tools, right? But you can put together various stacks of such tools
Mhm.
that
Mhm.
will build the same purpose.
Mhm. Okay. And what do you think? Which things we will see more and more? So you said that there is this postmodern air quotes data stack. She gets references like there was some modern, postmodern in art, right?
Yeah.
Uh, oh. So which things do you think we'll see more as like in 2025 and beyond?
So I think we'll see a lot more AI. Like the whole field is just starting. There is, let's say, a baseline level of use cases that can be solved currently, but this is growing with knowledge graphs. So basically, going in the direction of being able to solve more complex tasks with less hallucination. From what I can tell, I would say this is probably the biggest thing happening right now in the data market. And I would say AI is entering the field of data engineers. So basically, it used to be first that, oh, only AI engineers, whatever those are doing AI. Right now, it's going into the direction of software engineers are doing AI engineering, and this is right now data engineers in many teams. And prompt engineers are building last mile products, right? So it's kind of
Mhm.
like two different groups.
Mhm.
Um, Another technology direction is basically Iceberg. So I would say this is also big. What we're seeing is before it used to be mostly hype. Somehow this hype is basically transforming into reality and production deployments. So in the beginning of the year, we were hearing every now and then about Iceberg. People were getting excited about, let's say, what PyIceberg could mean. So, Pythonic iceberg.
Can
Uh,
you tell us more what this actually is? What is iceberg? Because I've heard iceberg, people throw
so
this, like, what is it exactly?
Okay, so basically, databases like a SQL database, for example. These databases have multiple layers. They have a storage layer, they have a compute layer, and they have an access layer, metadata. We can describe them in many ways. But essentially, what Iceberg is, it's a file format, it's a table format, we call it. It's a way of storing data independent of these databases that simulates, let's say, the storage layer of a SQL database. So it's kind of like a file, but you can have some logic on top of it that allows you to update it. You're not
Mhm.
actually updating it, right? You're actually just writing some data and invalidating the old one, unless you do cleanup operations.
Mhm. So
Uh,
it's, would I be correct saying it's just a bunch of Parquet files on S3 organized in a special way?
You could say it's a bunch of Parquet files along with some metadata files. Yes,
Okay.
that tell you basically which records from which Parquet files are valid. So yes, it's very similar to Delta. It's very similar to Hudi. And I would say the industry is super excited because this means the decomposition of the database. And you might be aware that in software engineering, databases are heavily vendor locked. So basically what this means is they are not competitive because vendor lock allow vendors to set prices that are maybe 10 or 100 times higher than what the product is worth. So breaking this apart would mean freeing this in the software space. But one thing that people are kind of getting wrong is here we're talking about the storage layer, we're talking about data, but really the way we interact with data will always be on the access layer, right? And we have vendors that are trying to sell us their compute in the middle, but fundamentally, this whole movement and this whole discussion about file formats, table formats, and where this is going is driven by vendors. So while basically vendors are still trying to use these table formats and capture value through a vendor log, through the catalog. And I guess what is really big and what people are really excited about is the concept of headless table formats. So basically what this would mean is that you're no longer using a catalog, that you are really free from the vendors and that you are writing, let's say, Iceberg files without using any kind of vendor service. You're just using those files with open source technologies on top. This is actually something that we're working on as well.
I just want to take a step back. So you said that a database are four things if we abstract many things, but like essentially it's four things: storage, compute, access, and metadata, right? And by catalog, you mean this metadata, right?
Yes, in fact, actually, no, I mean access. There
But
are two.
like, well, what are so storage is, let's say, a bunch of Parquet files on S3, right? So this is storage. Compute is what we use to actually go through these files and take things out of there, right? It could be
Let's say
Spark
Spark
or.
or DuckDB or
Mhm,
Python.
mhm. Okay, and then we have metadata and access. Metadata is like Hive or something like that, or what?
It's more like an information schema from the database that is telling you, what you can find there. And also it's just like, imagine when you are writing to a table, when you're updating a record, to do that to a file, you would need to read the file, rewrite the file, and delete the old file. So this is like a huge amount of data being throughputed when all you want to change is one record. So actually how this is handled is you add the information in another file, and then you say that this specific record should be consumed from the new file instead of the old file.
Hmm.
Basically, this is also a layer of metadata that solves the problem that files cannot be updated.
Hmm. Okay, and access is what?
Access is basically the online thing that allows you to, access the data, query it, control who has access to it, package it with compute engine that will be used.
Hmm. So it's basically the thing that puts storage, compute, and metadata together.
Yes, it's the thing that basically turns it into a usable product online.
Hmm. And when you say catalog, what is it exactly?
There are two types of catalogs. Basically, some catalogs serve the function of access. So it's just like a service that maps to data somewhere and to compute somewhere and allows you to access this data with this compute. You have access control, so you can actually manage that. And then there are catalogs that actually handle metadata that do all kinds of interesting things like lineage and so on. Those actually have a lot of, built-in utility that is useful for the developer.
Mm-hmm. Okay, and in terms of tools, what would it be?
Off the top of my head, I don't know all the tool names. So
Like, let's say, so I remember from my days when I worked, so for metadata, we use these Hive tables, I think. And then the files were Parquet files on S3, right? Um, so catalog is kind of similar to these Hive tables. Or there was another tool where it was
I
actually
would say
described.
if you were doing data lake, you might not have had the concept of catalog. But if you've ever worked with data lake on Amazon, maybe you worked with the Glue catalog,
Yeah,
like,
okay.
right? So this is just like access. But other catalogs have stuff like lineage, so you can understand, where is PII data or something like that.
Mhm. And by lineage, you mean there is a table and then there is something we compute based on this table and maybe some other table.
Yeah,
And we know
basically,
that.
Imagine you
Yeah.
have a data source, it contains PII, and this data source is then consumed to create various reports or data products. So you want to know that the PII probably ended up there.
Yeah, personal information.
Yes.
Hmm. And so Iceberg is the storage layer in this case. Compute could be anything, could be, I don't know, Databricks, Snowflake, DuckDB, I don't know, bunch of like a pandas, a Python script, right? So something that gets the data. Um, DuckDB would be compute, right? In this
Yes.
case, or
It would also be like a local access, but that's irrelevant because you want an online catalog, not local, typically.
okay. What do you think about DuckDB? Will we see? Because what DuckDB allows, maybe I'm again not correct in understanding what it's doing, but it allows you to do things locally that previously would otherwise not be possible. Like you would need to have like a Spark cluster, or I don't know, use BigQuery. But now with DuckDB, it can just fetch a bunch of Parquet files and quickly go through these files and give you the results,
I
right?
think I think it's amazing, and for us, it's actually a key technology. So what I really love about it is think about a SQL Alchemy database. SQLite databases, right? If you're using a mobile phone, which I believe everyone is, you probably have a few dozen or a few hundred SQLite databases running on your phone, right? What this is talking about, it's talking about the embeddability of this compute engine. So what does this mean for us? It means that we can actually assemble this as a building block into our own product. So one of the things that we do with DuckDB, besides just using it for demos and stuff like that, is basically I was telling you about putting these layers together. We released an interface in DLT where you can query the loaded data through a universal interface like SQL or Python. And why I say universal is because whether you're loading to file system, creating a data lake or a SQL database, it behaves the same. And what we do basically is when you don't have a real SQL database, we use an in-memory DuckDB for that. And we have an abstraction layer on top to basically make everything behave the same way under the hood, or whatever's under the hood. And yeah, basically this enables you to access data on the fly anywhere.
So do you think DuckDB, the appearance of DuckDB is changing how we do data engineering these days?
Yes, absolutely. So one of the things that I noticed is people are really challenging the concept of having to pay silly amounts of money to vendors for data movement or for data work. And one of my favorite setups that I've seen using DuckDB is basically leveraging DuckDB and files on GitHub Actions. So literally, there is no database. It's just all Python code, DuckDB, running on GitHub Actions, free tier, an entire data stack, data lake for a sizable company.
Hmm.
Cents per month over free tier, right? So
Hmm. So what with DuckDB, what we can do is, let's say we have some sort of data lake, which again, a bunch of files in S3 or Google Storage or whatever, right? With DuckDB, we can get them, process them, save the results somewhere, again, maybe back to this storage, and
exactly.
then have another script that gets the result and runs it.
Exactly. And because it's portable, this means you can take advantage. So just like the LT Plus, by the way, it means you can take advantage of, let's say, arbitration between compute vendors, right? So if I want to use GitHub Actions serverless, which is probably 100 times cheaper than doing the same operation on a rent, always on machine, whatever it is, whether it's, running Snowflake or Postgres, it doesn't even matter at that point. Yeah, it helps you, do new patterns and um, take advantage of technologies and compute that you couldn't do before.
Mhm. And is it related in any way to this headless tables format that you mentioned?
Um, yes, basically, Look, when I'm talking about these three layers, you have the access layer, and the access layer is typically online because this is where the tools are, because this is where the consumers are. But when you're actually working in the data pipeline, you don't need to go online. If you had a local access layer, this would be good enough. And DuckDB gives you this. So basically, it enables you to do whatever you want on local, which local to me means something that's deployed on production, running on a production worker, or it could also mean on my machine when I'm developing. Um, Sorry, I lost my track. Got excited.
But so you were talking about this headless table format, and you were talking about that with DLT, sorry, with DLT, this is something where you want to
Yes.
go.
Yes. So basically, this is something that we're already serving. So last year we were working with PostHog. They're like an open source analytics tool, and they wanted a headless Delta Lake. So we worked with them on this. We did this for them basically, and this is kind of like common pattern that we see. We help create these data lakes, whether it's Iceberg, Delta, or whatever. Then people do some kind of compute with their own compute engines, whether it's ClickHouse or DuckDB or something else. And then they push this data to an access layer. And this access layer might be Snowflake at this point, right? Because this is where the business people interact with the data.
Mhm. Mhm. Instead of processing everything in Snowflake and paying a fortune.
Exactly.
Because like in Snowflake, what's the business model? Like you pay per process
Yeah.
record or what?
You pay for, well, I don't want to go into details because
Uh-huh.
I will probably say something wrong.
Okay.
Not
But it's
using
expensive, right?
expensive.
Mhm.
And fundamentally, there are also benefits of doing it on your side that relate to portability. So what I mean is there are many organizations that use diverse data stacks and they have multiple access interfaces. So ultimately, they would like to do the compute in a portable way that is technology agnostic and then just serve it where people use it.
Mhm. Yeah. And other thing that appeared maybe not as recently as DuckDB, but fairly recently, if we talk about grand scheme of things, like for example, you've been around in the data engineering industry for quite some time, is it's DBT, right? So 5 years ago, nobody used it. People were trying to come up with their sort of scheduler or whatever for SQL queries. But now we have, I don't know if I can call it a standard, but we have this tool now, which is quite popular. So how did DBT change the way we do data engineering? And do you think it's going to continue changing that?
Um, That is a good question. I cannot speak for the future of DBT. They have some very interesting plans, and I don't quite understand them because there are a couple of directions. Maybe they're trying to broaden their offering. But essentially, yes, DBT changed a lot, not just how we do data engineering, but how people think about it. So before it used to be that people orchestrated their own SQL queries, and this led to people writing boilerplate code all the time, and it was horrible. To maintain, lots of bugs, and you're reduced to like a typing person at that point. Um, and what it changed, it kind of made people think, how can I do this better, right? So when it comes to the actual like SQL person, I would say for them probably not much changed. They're not thinking about the overall picture. They're just trying to do their work in the SQL database. But for the people outside of that, now there's no more boilerplate code. There's no more garbage to maintain. So it significantly improved, let's say, the quality of engineering in a project.
Mhm. And there are alternatives to DBT, right? Like SQLMesh and others. Like, what do you think about them?
Well, just like any product, there are, many alternatives, and that's not a problem, right? What a competition is healthy. It
Mhm.
means there is demand, and it means that there are diverse groups of people with different needs. What I think about DBT is that DBT is in a unique place because they were first. So, let's say growth was rather because of the concept than the product, I would say. And at this point, DBT is pivoting in a different direction, right? So they're doing more of an open core offering where they're offering things around DBT. And then there are tools like SQLMesh that are actually doubling down on what DBT Core was offering, which is a way for developers to work with their transformation code more effectively. And for example, if you're a data engineer that does a lot of SQL development work, you might be more effective in SQLMesh.
Okay. Yeah. And so we spoke a bit about SQL orchestration, but what about workflow orchestration? If we wanted to start a data engineering project today, what should we use as workflow orchestrator? Should we use any?
So that is a great question. We actually explored this topic in depth, and the conclusion is basically it's like ice cream. Pick the flavor that you want, and I would say it's not you picking the flavor that you want, but it's rather pick the flavor that your entire team can eat,
Mhm.
right? So different orchestrators.
Vanilla, right?
Sorry.
Vanilla.
Vanilla. So actually, this is the reason why people choose Airflow many times because it's the
Mhm,
vanilla. It's basically the common denominator that everybody
mhm,
knows. And
mhm,
I would argue, just like with DBT, there are many competitors out there that do specific things better. When it comes to our team, for example, if they haven't been exposed to Airflow before, I would say they gravitate to Dagster simply
mhm,
because it kind of captures their software development way of thinking and so on. If they have used Airflow and they want something better, they might go to Prefect, right?
mhm.
So it's, yeah.
Okay.
Personally, we actually often use GitHub Actions.
Mhm,
So, it's really like, it depends
mhm,
what you want to do. And
mhm.
there's no
'Cause-
wrong answer unless you
mhm,
have a very specific use case.
mhm. If you need a simple workflow, sequential workflow, then GitHub Actions would be sufficient, right?
The reason why I love GitHub Actions is because it's actually serverless. So it's literally like 100 times cheaper than,
Mhm,
putting it on some kind of always on orchestrator.
mhm. We have a few questions. I think it would be good if we go to the questions from the audience. Um, would it be effective for my learning journey and career development if I pursue multiple disciplines, for example, data engineering, data science, and AI engineering at the same time?
I don't think so. I think you should get clear on the type of role that you want to do. So basically, look, what kind of company do you want to work in? What kind of colleagues do you want to have? What kind of challenge do you want? And what kind of problems do you want to solve? And then learn for that space. You have time in your career to learn the other stuff. Just when you're starting out, stay focused.
Hmm. Yeah. And also when it comes to AI, um, a lot of AI engineering is actually data engineering, but called differently. Because, like, for example, if we take RAG, and if we think what exactly we need to do to do there, is connecting a bunch of things. And one of these things is a database where we store like where our knowledge is, right? Our knowledge base. And at the end, if you look at this, it's like, okay, we move data from here, this point to this point, and then from here, then we need to retrieve this data. It's kind of like, data engineering.
It's kind
So
of
what?
like thinking, right? So what I mean is fundamentally you have a few moving pieces. You have data, you have some kind of algorithm, which is the LLM. And then I would say there's something you haven't mentioned, and that's semantics. So what I mean is, there is this concept of raw intelligence. So like if you have some neurons in a petri dish, they will do things, they can solve problems, but it's a very basic thing that they can do. And if all the neurons are the same, then there's no specialization. But in a human brain, sometime I think like 60,000 years ago, because humans evolved in the context of concepts, we started to develop specialized brain structures that deal with these concepts. So the way you could think about it is the brain has a semantic map. Data should also have a semantic map. And basically, this would help an LLM understand how to work with data. To give you an example, if you are trying to, let's say, work with an LLM to place an order for a screw, and you give it the text, it doesn't actually understand what you want because a screw has dimensions. It has diameter, length, it has a type of cap. So in order for the LLM to understand how to work with that, you need to tell it, hey, this is a screw. This is what can be done with a screw. It has dimensions, it has diameter, and so on. And then the LLM can actually help you place an order for the screw.
Yeah, that's a deep thought. But speaking of, well, again, coming back to the topic, we're talking about trends. Another question is like there are so many tools in the field of data engineering, and also we have so many companies. And the companies promote it, or like the, I don't know, Snowflake will say, our computer is the best one. Then Databricks will say, no, ours is better. And then you have like, I don't know, Fivetrans and Airbytes and like, there are many tools. And then there is this postmodern data stack, right? Where we talk about DLT and other tools. So there are many tools and it's confusing. Like let's say I'm just entering the field and I want to select which tools I need to master in each domain. How do I select them?
So if you're just entering the field, I would discourage you from attempting to master any tools at this point.
Mm-hmm.
So I would say the most important thing is that you get the concepts of what you're doing right. So kind of like understand the problems in a generic way, and you are able to add value to a company by solving problems. Then when it comes to actual tooling, you can decide that later. Ultimately, if you want to work in software engineering, you need to adopt a different attitude than learning up front. And that is, you need to learn how to learn. And you need to have the attitude that this is how you succeed, because you will have to learn every day. And you shouldn't be afraid to say, hey, we're going to solve this problem. I haven't reached the technology decision yet. And when you get there, you might spend half a day to explore options and then make a call.
Mm-hmm. But let's say I don't work yet. So, okay, like adding values to the company is a good thing, right? There is a problem, I want to solve this problem, and then like together with the team, we select the best way to solve this problem. But I just want to, let's say, build a portfolio.
Okay,
How
so
do I
if you're
select the
trying to
tools?
do that, ignore the vendors. Don't worry about it too much. No one will hire you as a specialist on Snowflake when you're just starting out. So, don't go there. Rather learn SQL, right? Learn Python, learn data ingestion, learn data transformation, modeling. But most importantly, learn how to capture business requirements and solve problems, because this is what you're hired for. And the reality is that unless you're joining a senior team that can give you a framework, you're gonna have to figure that out, and technology is secondary.
And would you say just picking, for example, we have a course, right? And the course we say, hey, there are these components, like, I don't know, you need to um, have a data lake, you need to have some sort of workflow orchestration, you need to know SQL, right? And then, like, I don't know, present data somehow. Would you say just selecting any tool for each of these sub-problems would be okay?
So I would say when you are solving problems, you will have requirements that come up, right? So I encourage you to try these tools and learn them upfront, any in each category ultimately. But when it comes to visualization, you have a decision to make. How am I going to deliver data to this company? And depending on who the consumer is, you should consider them as a person. And can I get them to access data through this interface? Will they understand what they're doing? Right? So, like I keep saying, if you know some basics of how to do things, that's enough to start, right? So if you're joining a company and your idea is that I will display data in notebooks, this is not wrong. It's not the best way, but it's better than what they have probably, right? So ask them, do you want your data in notebooks? And they're gonna say, what's a notebook? I don't know what a notebook is.
Mm-hmm.
Can I have a dashboard? And then maybe you're going to go to free Google Data Studio and you're going to do some dashboards there. And then you're going to find some limitations. And then maybe you'll ask somebody who has more knowledge and they will give you a way to think about it.
So basically just try things and see where it's going.
Yes, basically the modern data stack is extremely interchangeable. It's extremely commoditized. I would say if there's one thing to take care of is that in a commoditized market, revenue is hard, which incentivizes vendors to adopt black hat tactics. So this is something that I would look out for. I would look out, are these reputable vendors or are they going to rip me off? What does their cost structure look like?
Yeah, interesting. And well, you said that at the end you're an engineer, and then you should think about problems and how you solve these problems and how you add value to the company. And then you don't need to be a data engineer for that, right? So the reason where I'm going. So there is a question: how challenging it is for a senior backend engineer to transition into a senior data engineering role. And I was thinking that as a senior backend engineer, so they probably already know how to translate, these problems into solutions and thinking about adding value to the company, right?
I have the specific experience. So actually, when we were building DLT, we tried it with different people. And I would say the knowledge gap for a software engineer is, of course, not software, right? But it's going to be in understanding the business case of what they need to do. So what I mean is, if you ask a random software developer, give me a pipeline that brings my HubSpot data into BigQuery, they will do that and you will have some kind of output and then you'll have to chase them. Hey, this is not fine. This is not fine. This is different. This is not logically working properly. The business logic here is wrong. And if you give it to a data engineer, they will work back from the requirement. I need to produce these reports because this is the business requirement. For this, I need to grab this data. This data has this logic of incrementing. And then you work back and you build a pipeline and it's usually fine.
Mm-hmm. Yeah. Okay. So basically, a senior backend engineer can transition into a senior data engineer role.
I would say it's quite easy. So,
Okay.
and I would say technology is not the obstacle usually, unless you're going for something like super specialized, but that's not at entry.
Mm-hmm. Okay. So if you want to position yourself as a Spark expert, then maybe you'll need some time to actually understand Spark in detail. But if you want to position yourself as a engineer who can solve data problems, then it's another thing, right?
I would say if you're trying to position yourself as a Spark expert, I will look at the portfolio of your work. So
Mhm.
if you're doing this as a junior, I will have a giggle.
Yeah, understand. Another question. I'm a senior data engineer from the UK, and I don't see any data engineering jobs here. Is the situation same across Europe and elsewhere? How is the job market overall? I don't know if you have exposure to that, but maybe you have some visibility, you have some ideas.
I don't have firsthand exposure since I'm not looking, but I hear about it from people. And basically, what I hear about is that if you're a senior in the field, there's no problem to find work. And I actually have former colleagues that have recently gotten jobs, like because they wanted to transition or change. So I would say I would try to look at where those jobs are, what kind of jobs these are, then maybe try to look at what could I do. So if I'm a if I'm a junior data engineer in the UK and I cannot find any junior data engineering jobs, maybe I can find, I don't know, BI manager, maybe data scientist, maybe something that will allow me to, get a job. And then once you have a job, it's way easier to get a second one.
Mhm. Yeah, right. And then there are quite a few other questions I wanted to ask you personally, and I wanted to come back to them. And so first of all, we talked about Apache Iceberg, and then you mentioned Delta and Hudi. Um, what are these things? So Iceberg is this, as we talked about, this is a special ways of organizing Parquet files in such a way that if you want to change something, instead of changing, you append to this data, and then there is like a smart way of saying that this record is no longer
Yes.
Good. There's another more fresh one, right? So this
Yes.
is Apache Iceberg. So what are Delta and Hudi?
The same thing. And basically where they differ is a little bit in design. Like where is the metadata stored? What kind of things is it good at? Is it optimized for streaming? Is it optimized for batch? What does the maintenance look like? Because there is the maintenance operation of cleaning up the redundant data, right? So I would say Delta is probably the most mature implementation. Hudi is quite specialized in the open source. Iceberg, I would say, if you're using Spark, it's fine. If you are waiting for PyIceberg maturity, I would say don't hold your breath. Um, yeah, so I would say these file formats, you should consider them more or less interchangeable and go for whatever you can work with right now. You can always convert them later.
Okay. And are they all, so since it's a bunch of files at the end in some sort of file storage, I assume the way we process these files and access these files is in a batch way, right? So there are some files, we scan these files, we produce some answer, and we maybe do this every hour or every day or like
Yes.
similar. Are there like this is batch, but what about streaming? Like, can we use these things if we have a stream of data?
Yes, it's basically exactly the same thing. What is streaming? Unless you have a very hard SLA, it's micro batching, right? So everything that is streaming without a hard SLA is micro batching. So, when it comes to these file formats, I would say the distinctions of how well they can handle streaming is on, let's say, the speed of read-write operations and maintenance.
Mhm. Okay. But
That
so
being said,
where
don't try Iceberg with streaming right
uh-huh,
now.
yeah,
Have lots of people telling us it's a bad idea.
so it will produce a ton of small files, right?
Performance is a problem, basically, but you can use Delta, for example.
Delta. So what I was trying to say is, or figure out, find out is if we need to do something like this, and if we want to use this sort of access storage layer, then it's mostly suited for batch workloads, right? For streaming, we need something else. What do people use for streaming these days?
For streaming, first of all, you need a buffer, right? So because you need to have some kind of service that is always available very quickly, that ideally implements some kind of protocol with retries. Um, so that's gonna be probably Kafka or SQS. And downstream of that, it could be anything. So for example, I would say Kafka is actually one of our top sources in DLT, right? So you talk about streaming. I would say people don't think about streaming in terms of strict SLAs, and it's usually micro batching. I would say the tightest deadline that I've seen outside of pure streaming is 60 seconds. Many people talk about streaming on 15-minute intervals.
Mhm. Okay. Um, so what kind of tools do we? So we use Kafka CQS, right, for
Yes.
SQS for streaming. But what do we usually solve? What kind of problems? So what I'm trying to ask you is, okay, we have batch, we have streaming. When do we actually need streaming? And like, have the tool changed? Because Kafka has been around for long time, right? SQS also has been around for a very long time. Like, are these tools going to stay, or you see some other trends when it comes to streaming and like new tools appearing, more
Basically,
maybe
when you have
convenient tools?
events, you need a buffer. It's not negotiable. So you
Buffer is Kafka, right?
yes, so you can use a different buffer. You could write things to S3, for example, but if you do that, the API cost of doing that will be ridiculous, right? So it's just, I don't think these will go away. I think what will change is maybe how people use it. And what I mean is initially Kafka was very much used for streaming, for capturing events and then doing something with them. Nowadays, I'm seeing people literally throw everything in Kafka. Just now they have a standardized layer and they work with that. Is it a good idea? It depends on the team. If you can only handle Kafka, then yeah, it's a great idea.
Mhm. And then so Kafka is just a buffer, right? So we can put some data there and it can stay there for some time. But then usually we use something else to read data from Kafka. So it could be, I don't know,
Yeah,
Apache Flink or
yeah.
like other.
I don't actually know that much about how Flink is used, but I know that some people use KSQL to read from Kafka. Other people use basically just DuckDB to take the data out and process it before loading it somewhere else. So
DuckDB can also do that, can it?
yeah, I mean,
Amazing.
you glue everything with Python ultimately. So
Okay. And DLT too, right? You can connect to. I
yes,
think you mentioned that. Okay.
it's
So
actually
basically, yeah.
we are quite heavily used as a Kafka sink because, if you're using Kafka as a standard layer, then, having a standard ingestion downstream is just nice.
Mhm. Yeah. Okay. And yeah, I see a question which is related to what I also prepared. So the question is, do you think data engineering will be automated by AI? And like in general, how does AI affect data engineering?
Great question. I think it goes in the direction of this commoditization and having to offer innovation. So basically, AI is speeding up the commoditization by making it easier for developers to work with AI. So, for example, we see some of our users are using Cursor or Continue or Windmill IDEs to develop 2 times faster, essentially. Um, and basically, what this will do is, I like to call this the era of disposable code, basically, where people are generating, let's say, basic code that is very disposable. And let's say, differentiators that will have to exist will be around use cases. So basically, I think data engineers will go deeper into their specialties. They will learn how to use AI more. One of the things that we're doing is many people in the industry call us AI enablers. The reason for that is basically because we provide an easy way to feed data to LLMs, AI,
Mhm.
stuff like that. We're also working as part of this Anthropic startup program for the MCP. So basically what this does is this adds that semantic layer that I was talking about that you need together with your data and with the algorithm to be able to create intelligent AI agents. I mean, beyond just a RAG or just
Mhm.
sort of prompt engineering. Yeah, this is something that I'm actually quite excited about because it will enable you to feed DLT data into a standard that accepts metadata that will then be used by the AI.
Mhm.
So I think
Yeah.
data engineers will end up building AI agents.
Okay. Yeah, interesting. I think recently, I think you published an article, right? I saw it on your LinkedIn from somebody, maybe from this, from the network you mentioned, or
Mhm.
from the partnership companies who used AI to make things way faster, right?
Yes.
Okay.
So basically, what that article talks about, you can find it on our blog. It's literally a guide of how to do it yourself, coming from a senior data engineer that is using DLT and Cursor together.
Mm. Okay. Okay.
Open
Do
source.
you have
I encourage
do
you
you
to
have a
try.
couple of more minutes?
Yes.
Because so the last question I wanted to ask is the place of DLT in the ecosystem. So you said it has already become a standard for ingestion, and right now you also shared some plans that you want to maybe go uh, to give more focus to become this AI enabler. You already are, but like maybe double down on that. So what are your plans for, let's say, 1 year, and where you see DLT in 5 years?
So 1 year is DLT Plus. It's basically building out this data platform around DLT. It's portable. It's really cool. It enables new things. What it also does is it enables you to package data products in a portable way. So, and this is the reason I mention it is because it plays into the bigger vision. What I mean is I was telling you about this stack agnostic access, right? So if you build on top of the stack agnostic access, it means that you can use the same code on any technology, which means that now you can reuse things across organizations. So this is actually, part of the commoditization story is Fivetran and all the other vendors commoditized maybe 300 sources. And if we are to talk about them in the concept of raw data or bronze, as Databricks would call it, and then silver and gold, you could say that the industry is currently selling bronze or silver data sets, and it's 300 of them. What we're trying to create is the infrastructure that will enable participants to the industry to create a marketplace for bronze, silver, and gold data sets. So what I mean is essentially data products, whether they are sources, transformers, or AI agents. We want to create a marketplace that will enable people to offer their creations and have them reused.
Mm-hmm.
So that's the DLT Hub. That's the long-term vision.
Mm-hmm. So this is in 5 years.
I hope sooner than that, but
Okay.
yeah, in 5 years, hopefully it will already have been around for some time and gotten to some
Yeah.
size.
Well, so since it looks like we already have a tradition to talk in January every year, so probably we will have another interview in 1 year and see how things will have played out by then. So it was amazing, as always, talking to you. Thanks, Adrian, for joining, sharing your opinion on how things have developed and will develop. It's very interesting for me personally, for the students. I see a lot of actual engagement. So thanks everyone for also joining us today and being active for questions. And yeah, it's been fun. Thanks, Adrian.
Thanks, Alexei. See you later.
Goodbye. Bye, everyone.